Good afternoon, everyone. Pratik this side. I'm an application engineer in integrated microsystem, and today I'm here to and today I'm here to present about optimizing implant fit and performance with image-based workflows using Synopsys Simpleware Software. So let's start our session. First, let's see what Synopsys Simpleware Software is. Then after this, we'll go into implant and other features. So basically, Synopsys Simpleware is a 3D image processing and segmentation tool by which we generate 3D models. We can do 3D printing. We can do finite element meshing, computational fluid dynamics meshing, knobs meshing, and we can directly export them to their solvers, finite element solvers. And if we are going for 3D printing, we can directly export it to uh, like CD disk view. And there are a lot of import and export capabilities available in this software. So this software covers various parts from craniomaxillofacial to orthopedics, covering the cardiovascular part also. So today in this session, we are going to cover the orthopedics implant. So in orthopedics, there are basically basically when we talk about implants. So what we can say is we have a dental implant and orthopedics implant. So these are the hard tissues available in our uh, human body. So uh, this first diagram shows you the craniomaxillofacial and segmentation visualization in this Synopsys Simpleware software, and how we can do the measurements and pre-processing before the implant fitting. This hip joint segmentation with implant overlay. So basically, this is showing the acetabular cup implant in our hip region, and this is the right hip. And so basically, we will going to see this example in today's session, and we can directly export this scene to the disk view and directly go for 3D printing, and we can go for surgeries also. Moving forward to the end-to-end implant design workflow. So basically, this Synopsys Simpleware works with CT scan, MRI scan, and it can import other images also, like raw images, 3D STL files also. So after image acquisition, we can go directly to the pre-processing of images, like marking our region of interest, going for cropping tool, and there are resample tools, rescaling tools available, pairing tools. So we can directly pre-process our data, and if we don't want any specific uh, part of our 3D rendering, so we can directly cut that portion out, or uh, and select our region of interest. Then we can directly go into the segmentation option. So here in Simpleware we have three types of segmentation. One is fully manual segmentation, second one is semi-automated segmentation, and third one is fully automated segmentation. Simpleware allows us to work on fully automated segmentation with the help of artificial intelligence. So it within a few clicks it segments our complex data sets, and the mass quality and efficiency is above 99% in the case of orthopedics. Then we can go for CAD integration. After the segmentation, we can go for uh, importing the surface. For example, in today, we're going to see the acetabular cup in the pelvic area. So, for example, when we go for uh, hip replacement surgeries, or different types of implant fitting, so this basically helps as the human uh, body structure or bone structure. that can help the human throughout his entire life. So we will talk about permanent implants, we'll talk about temporary implants, we'll talk about replacement implants. We'll see the visuals. Okay, so there might be some glitch. Uh, so I was talking about the CAD integration. So in the case of hip replacement surgery or hip, so we have basically this acetabular cup, and other than acetabular cup, we can use a ceramic metal ball in the place of the cup. But today, in this example, we'll see how acetabular cup will helps us in implant fitting, and we'll see the pre-processing before fitting the implant. After that, we can go for finite element meshing, and we'll see how meshing can volume rendering, or sorry, volume meshing can helps us in uh, basically simulations ready. So we can directly export it to any simulation software with the help of like .inip format. Moving forward to the core features of Synopsys Simpleware software. So basically, it has three major parts. First one is scan IP. So scan IP is the basic structure or base of the Synopsys Simpleware software. Here you can directly import your DICOM files, raw images, and you can visualize them. You can go for the manual segmentation, and after manual segmentation you can go for the 3D printing. You can go for the .stl generation, and there are other export capabilities available. Moving forward to the FE mesh, or we can say volume mesh generation. So basically we need FE mesh to export our data set into the solvers of finite element analysis, for the finite element analysis and computational fluid dynamics analysis. So basically this helps us in stress or strain analysis and other analysis. Moving forward to the knobs, basically it is non-uniform rational B splines. So it helps to import the CAD and directly work on the design link to help the complex bone geometry, and it can directly be exported via IGS. And you get three of this Synopsys Simpleware, three major parts in the research bundle. Moving forward to the Simpleware for orthopedic implants. So as I've told you, when we talk about implant, so if we have, if we are dealing with the heart tissue, so we have dental implants and orthopedic implants. So today we are talking about the orthopedic implants. So basically, what Simpleware can do in orthopedic implant fitting or implant management. So basically, it can help to fit or to create the perfect geometry to fit the uh, specified uh, acetabular curve, or we can say our prosthetics, to specified area of human anatomical structure. So we can directly visualize and fit our implant. So after that, you can go for 3D printing with the help of high quality STL files. You can export them. You can basically you can directly import your surface from the CAD capability available in the software. And before that, you can basically do the pre-processing, and after that also you can do the processing while fitting the implant to its proper way. So after that, you can go for if you want to go for finite element meshes, you can directly move forward to the finite element meshes. Moving forward to the implant positioning and a design link with the help of like SolidWorks links is help in this software via design link. So in many of the tool ribbons, you get the direct link of design link to incorporate Simpleware capabilities into SolidWorks, and vice versa. You can directly import and export projects from SolidWorks to Simpleware with the help of the design link. And with the help of the Simpleware CAD capabilities, you can directly import the objects which are available in STP, IGES, and .stl. So it can show the basic structure window first. You can see its all the properties, and you can directly change its properties according to you. Moving forward to the implants. Now let's talk about the implants. So as I've told you, there are uh, various types of implants available. So for when we talk about implants, in the hard tissue implant, we have this dental implant and we have this orthopedics implant available. So when we talk about orthopedics implant, so we have implants for knee, we have implants for ankle, we have implants for hip region, we have implants for shoulder regions, and more. So we can directly work on this shoulder and knees, ankle, hip. So these are some capabilities that are available in Synopsys Simpleware. Directly, you can work on the automated segmentation and you can go for the implants. So in the case of orthopedics, Simpleware is a very efficient when you talk about implant fitting. So basically, we use these implants when we have to do the knee replacement surgeries or some fracture has uh, undergoing. And other than that, there are some cases of arthritis also. So there are two types of arthritis. One is the obvious one in which people get old and they get the arthritis, and second one is the immune system. So you can get uh, basically depending upon your immune, your knees can get that disease. Moving forward to the orthopedic implants. So basically, in orthopedic, it is considered as the medical device to replace our bones, our heart tissues to support our human structure as long as our life is. So when we talk about the arthritis, it has two types of arthritis: osteoarthritis and rheumatoid arthritis. So when we talk about osteoarthritis, so it is like when people get old, they get the arthritis, and when people get injury, then also it is considered osteoarthritis. But when you talk about the rheumatoid, so it is when people get their immune system very low. So that causes arthritis in some people. So in that case, you can go for the implant fitting, and these implants are very efficient in helping the body structure, human body structure. And also it comes in temporary ones and permanent ones. So permanent ones will go along throughout your life. And when we talk about the temporary ones, we have screws, pins, wires, nails, and plates available. So it helps when you get some injury, and it basically be there till you heals. So let's talk about the permanent implants. So when you're working on hip replacement surgeries, ankles, shoulder, so Here, when you talk about the replacement, so it basically uh, be the permanent implant. So it is helping up your human body structure throughout your life. So it will be the permanent implant. And when you do the like implant surgeries, so it comes with various features like it is corrosive resistant and it is wear and tear resistant. So these helps in basically when people go for implant surgeries. So these are some things that helps uh, people to build trust over implants. And next we have the temporary implants. So as I told you, when we get some injury or there is some minor accident happens, so it comes in screws, pins, wires, nails, and plates. So it helps the body structure temporarily and be there till we get healed. Moving forward, the hip replacement implant. So, when I talk about the hip replacement implants, so it helps the basically structure of human body. You can go for the total hip replacement surgery as well as you can go for the femur implant also. So it is acetabular cup, and other than that, there is a ceramic ball implant also. So when we talk about the hip joint, so uh, basically the artificial implants will be there, and it will be uh, there on the top of the femur, and it called as a thigh bone. So it will replace the thigh bone and the socket also, which we called hip bone. So basically, we can replace both of these parts, and we can go for the artificial implants in place of this through the lifespan. Moving forward to the parts of hip replacement implant. So as I've told you, first is the metal cup that basically will be your acetabular cup, and it will be uh, a semi spherical cup that helps your movements in the pelvic region, and it will be there in the top of the femur. Second one is the ceramic ball. So it is a basically a ceramic ball. It will be attached to a metal stem that will also be the implant. So it will be inserted in the thigh bone for the stability. So in the past, metal ball has been used, and it is replaced to the ceramic ball nowadays. Here are some visuals of the implants. So first one we can see it is the hip replacement implant or hip implants. Here is the acetabular cup, and this is your femur bone. So and the top of the femur bone is called femur head. So it will go inside the femur head, the acetabular cup. So that is why it is semi spherical. This one is for the knee. So here you get the two types of implant, two parts in this implant. So first one is the upper part, and second one is the placer, plastic spacer we can say. So the first part will go in the femoral component, and second part is going the tibular component. Moving forward to the shoulder one. So in the shoulder we have this glenoid sphere, and it is also comes in two parts. So this one will move and this one will stick to the clavicle bone. And last we have the ankle implant. It has also two different parts. First one will go in the tibia and second one will go in the talus. Moving forward to the orthopedics auto segmentation feature available in this Simpleware software. So basically, when we talk about auto segmentation, it covers various parts. In the case of orthopedic, so we have knee CT available. we have a PD weighted knee MRI available, we have hip CT available, as well as hip revision CT available for the metal artifacts available. If so, next we have ankle CT available. Then we have shoulder CT available, spine CT is there, craniomaxillofacial CT is there, and uh, in the cardiovascular region, we have basically heart CT is there, and aorta CT is released in the new version. So this basically helps us to make our task very fast. Like when we go for the manual segmentation. So if you are going to do the segmentation of a knee with the help of manual segmentation, you will be taking 30 to 40 minutes to do the full segmentation. Whether you go for the automated segmentation, so you have to click in the auto segmentation, you have to click on the knee CT or knee MRI if you are using. So you have to click there. You have to click on the keep all the bone fragments and create landmarks. So these are additional filterings, and after that you can go for the apply. So that is all you have to do. And after that, within 1 or 2 minutes, it will segment your knee CT as well as other CT options available. So as I've told you, manual versus automated segmentation. So one can say like if automated segmentation is doing the task within 1 or 2 minutes, whether manual segmentation is taking 40-50 minutes. So can we trust that segmentation? So you can go in the mask similarity calculator. When you work on the segmentation, it will create the mask out of it. So when you go in the mask similarity calculator, you upload or you select the mask that I've created by automated segmentation. So you will find it is to be the 100% or more than 99% of efficient segmentation. So automated segmentation, with the help of automated segmentation, you can also check the efficiency or basically the segmentation quality of the mask. So that is why we have this mass similarity calculator available. Moving forward to the new features that are uh, released in the Y 2026.03 version. So first one is the new mirror tool. So basically, it helps in the surgeries when we work on the visualization or segmentation. So it helps us to divide our plane into two parts, and it can be interactively visualized there. So this new mirror tool is has been released. Next one is aorta CT segmentation. First, we have only heart CT segmentation available, but in this release, we get the aorta CT segmentation, and its landmarking options available. And after that we can go for the CFD meshing for inlet and outlet definition. Then we have this expanded 3D PDF export option. So basically I'll talk about this new features in the next webinar, specifically for the new release. So then we have the expanded 3D PDF export, in which we get all the documentation and basically deep documentation in this 3D PDF export. Then we have the improved finite element meshing for thin regions. So first we have the primitive option available for when we go for the FE meshing. We have this primitive option in which we can in the specific part we can create the primitives in the form of spheres, rectangles, cuboids. So it can help that specific part to do the FE meshing with high efficiency. So now it uh, has more improved when you go for the thin regions. So it has improved in the thin regions. And if you talk about the finite element meshing, and after finite element meshing, if you are not satisfied with it, then another feature is also available, that is the basically the structure editor is available or a feature editor is available there, so that can help if any triangulation is wrong or any edges are there, so it can help to like remove that. Then we have this hard report tool option feature available. So when we are working on hard segmentation, so it can help to generate a report out of it. Moving forward, these are the system requirements for using this software. So this is basic requirements: 16 GB RAM and i7 100 GB of free space. So these are some requirements. Next, we are going to see the live demonstration of the software, and as well as we'll see one example of the orthopedic implants, that is SWR cup. So let me share the screen now. Yes. I hope my screen is shared, and I'm going to open this software. So you can directly open it with the help of typing name Simpleware. So Simpleware Y2026.03 version. So we have recently received this version, and after opening the first GUI you get, the interface you get is this interface, in which you get all the tool ribbons options available here, from home, image processing, auto segmentation, software tools, volume mesh tools, measurements, 3D printing, view tools, and you can directly work on and modify your specific tools and add it here. And next one is help tool. If you are stuck somewhere, so you can directly open this help tool, and help section will open in the sidebar, so you can simultaneously work on your specified project and specified case, and as well as see help section. Then when we come below, we see the project information option available here. So whenever we import any specific DICOM or something, so it will show some geometric properties here, object counts here. Then we have this a new project import options available. So we have DICOM import capabilities available here. For example, CT scan, MRI scan. Then we have the DICOM images option for industrial DICOM images, in which we can also import uh, micro or uh, micro CT option is also available there. Then we have the spec server option available when we are working on in hospitals. So spec servers, we can directly import any specific patient DICOM. Then we have raw images import capabilities, 3D image formats, .stl or CAD file option available, and many other option available to import volume mesh file. Moving forward to opening the example that we are going to see. This is the recommended projects available here that we have opened earlier. I'll go in this file option, new project. From here, I'll select the DICOM images. In the DICOM images, I'll click on the scan folder, and in the scan folder, I'll go in the Windows C program files. After program files, we'll go into Synopsys Simpleware. Then we'll select the version. In the data, these are the example cadaver data available uh, by Synopsys Simpleware. Let's go into the pelvic uh, data set. So I'll just click on this pelvis DICOM option and click on the select folder. So it will see all the DICOM files inside it, and visualize all the images into one series. I can see from here how many images or slices that are available here. So the total number of slices are 280. Here, the details of this DICOM data set is available. Like we can see a lot of information from here, like what is the modality, the CT, manufacturer assignments, and other uh, properties are also available here. We can directly anonymize this, and we can also store these. Then I'll click on finish. So after finish, it will give me an interface where I can see three 2D images. So these three are first is coronal axis, second one is sagittal axis, and third one is axial axis. So you can see how it is visualizing. And the third one is like this. And the fourth one that we see is the volume rendering option available. So this is the volume rendering that has been captured by this software through the DICOM that we have imported. We can expand it since the most of the work that we are going to do is in the 3D mode. So as I can see, my imported project has many artifacts and noises available. So I have to remove it. First, before that, I can go in this background volume rendering. So it has many presets available. For the bone, it has this preset available. So I can directly load it from here. And we can directly modify our DICOM volume rendering from here with the help of this histogram is available. And then we can directly uh, do some valuing here, and we can on the basis of color we can directly change its color values, and after that we can close it. So I'm seeing a lot of noises. So first let's go into the image processing. I'm not going to use the manual segmentation since it will take a large amount of time now. So I'm going to use some specific options from here. So first one is the crop tool. So basically the region of interest is this much only, so it is going out of the region of interest. So like this I can directly shorten up the region of interest. We don't want this option, this portion of vertebra also, so we can directly remove it in the further options. After this we can go for rescale or resampling option. So it can directly, currently our data set memory is 68.81 MB. So it works like when we reduce its parameters, like if I do 0 0.4, 0 0.4, 0 0.4, 0.4, 0.4. So if I half the values, so it will make the sampling parameters, it will uh, upsample it. So it has increased its sampling from here. So I'm just undoing it. And with the help of this rescale, you can directly change the physical parameters. With the help of align, you can align the basically specific access to the project. Register data sets, we can directly add any surface object from here. Shrink wrap, it is the basically works like the crop. It helps to shrink the region of interest uniformly. The pad works vice versa, so it increases uh, the region of interest uniformly. Moving forward to the segmentation, here are a few options available that we are going to use. First one is threshold. It is the major tool that we are going to use. So it has a histogram available, and also it has presets available. So currently I'm working on bone, so I'll select 230 to 3020 lower and upper value. Click on fill cavities on the resulting mask and only keep the largest resulting island. So after it, I'll click on apply. The output is the new mask. After it, I'll click on this. This option is the generate a fast preview option. So as you can see, it has removed all the artifacts that are available, removed all the noise, only kept the largest resulting element, that is this one. So currently, it is also available in various parts, but it is one unit currently. So this is sacrum, this is our right hip, this is left hip, this is femur, right femur and left femur. So we can, with the help of the split regions, we can directly segment it out. First, let me work on this simple 3D editing. So with the help of this delete tool, let's go inside it a little bit. I'll click on this delete tool like this. So it is disconnected the larger island to the smaller island. So after this, how can I remove this? So with the help of this mask flood fill, open this mask flood fill. So what it will do, it will, with the help of the operation of flood fill and in the mode of the 3D, currently open the 3D option. So it will replace the output and replace the smaller island and keep the larger island with me. So if I click on this larger island, it will remove the unwanted part from the region of interest. So that is how you can use the mask flood fill. Moving forward, some filters are available. So let's use bone filling filter for now. So these are some filters. If we are working on the DICOM data, we know DICOM data is not as uh, efficient while we do the visualization. So we need some filters to fill the bones. We need some surface correction filters option. We need some cavity fill option, gaps fill option available. So we require these options or filters to help us get a better visualization. So it has done my task. I'll do the generate a fast preview. So as you can see, it has increased its efficiency. Like the previous one was not that much efficient in the basis of visualization. So now you can see it's highly appropriate now. Moving forward, this was the image processing part in which we can directly do the pre-processing manual segmentation, as well as the auto segmentation is also available, multi-level auto segmentation, and filters are also available. Moving forward to the automated segmentation. So I'll import the DICOM again, finish, and directly go into the auto segmentation and hip CT. So it has many options available, as I've told you: ankle CT, knee CT, knee MRI, hip revision CT for metal artifacts, shoulder CT, spine CT, and craniomaxillofacial CT. So I've selected this hip CT. I can directly import a specific part and deselect any other part, but right now I want everything. So I'll go for the create landmarks and keep all bone fragments clicked. I'll click on apply. It will take my few seconds on the basis of the system you're using. So it will take hardly 1 minute of mine. So we have seen the manual segmentation, but we have not splitted the regions. But in the automated segmentation, there is no requirement of pre-processing. There is no requirement of crop tool. There is no requirement of any other filtering option, any other 3D editing option to remove any specific part. It will remove all the unwanted part, and it will directly generate our structure like this. And segment it into 5 parts that I've told you: hip right, hip left, sacrum, femur right, femur left. It has done its task. Let's wait for the summary to come. So summary has come. So it has generated 5 masks out of it, as well as the landmarks. So the landmarks will help us in the measurement tools. So I've created my segmented structure here. So you can see the efficiency of this automated segmentation. I can directly work on any of the specific part. So let's work on hip right for now, and can directly work go for isolate, but I have closed everyone else. So not this one, isolate. So now I can see my hip right option, and here uh, on the top of the femur right, this is the femur head is available here. So in the femur head, we have to fit our acetabular cup, and this region will be responsible for our better movement after our implant fitting. So moving forward to the implant fitting, we'll go in the surface tools, and in the surface tool, there are a lot of options available. Let me go into the import surface first. So import surface, after import surface, where is my acetabular cup is available. I'll go in the data, pelvis, and here is my acetabular cup implant available. So it is a 3D object or available in the .stl format, and it is showing in this window the number of polygons it has, points it has, is it watertight or not, and other properties of it. You can directly go for the import. So as you can see, this is our region of interest. This is the SWR curve. So currently it is out of our region of interest. So what basically we do, we go for the zero positioning, and I'll click, the target is selected. I'll click on apply. So after applying this semi-spherical cup is available in the zero position, I have to uh, position it here. So what I can do, I can go for the register datasets option, can select the current project, and the current project I have to select the surface, and after the surface I have to click on the apply update option available here, and after update it is updated in the specified region, and I click on next. So we are going to register it in the hip right options. Currently it is showing over the volume rendering option, the DICOM that we have imported, but we want a hip right now. So I'll select on the hip right, and in the registration method I'll select on the automated option. So now what I have to do, I have to brush out in the triangular selection. I have to brush out this region. So how I will do, I'll select the brush, go like this, mark the region that is only necessary, like not more than that, not less than that. So that is enough. And here also, so we have to brush out this part, not the inner part. So we'll go in the triangular selection, we'll click on brush, and we'll select this additional option available, that is grow selection below the angle threshold. So what it will do, when you just click on this, so it will draw the available surface, that is the back surface, and when you see the upper surface, so it is not marked. Then I'll go update here. So it has done my 90% of work. I just have to drag and position it. So I'll click on finish, and after clicking on the finish, I'll go for the position and orientation. So let's position it. So that is how you can go for position and orientation, and with the help of these arrows. So I think this is enough. Let me go inside more. It is not uh, interfering with anything else. I can see it here. So I'll, yes, and I'll click on apply. So after that, the implant is fitted perfectly. So more over to that, what we can work on our specific data to help our implant or our prosthetics fit perfectly with all the geometries it has available. So it has many other options available. So for example, it has option available of the create primitive option. So a primitive is basically the option when we are working on some specific data sets and we want some specific part to be when we are working on any operation to the data set, so we want any specific part to be more efficient, or we want that operation to be more efficient on that specific part. So that is how primitives are used. So it has options with sphere, cuboid, cylinder, cone, tube. So I'll select anything, and with the help of uh, by drag and mouse drag and views, click on start. So that is how you can draw this primitives. So currently I do not want this. I'll go for the sweep center lines, but before that I have to go in the measurement options. So for instance, let's see the measurement options. So from here, uh, let's just uh, hmm. So in the measurement options, I'll click on the create. So let's see the femur left option. Hmm. Let's remove this for an instance. Let's remove that for an instance. And now it is working. So close it, and let's work on the femur only now for now, since it has also work in the this head has also work in the implant fitting. So with the help of this create center lines from your right, I'll create the center lines from here. So what basically this tool is doing, it is going into its internal parts and working on specific points to give me the geometry it has available. And after that I can go for the center line editor to drag and drop or any modify any center line. Then we have this cross sectional measurement option available here. So let's see in the next option. From here we can see the line length of the specific line. So total length we can see is 229.017 mm right now. So we can select the select visible. So when we select any specific center line, it will show the total length of that specific center line. Moving forward to quick line analysis. So it has many options available, like best fit circle, how will it look, bounding ellipse radius, circumscribed radius, cross sectional area. So I'll see cross sectional area from here. all visible. And from here, show cross sections. So it has generated all the cross sections that can be possible in this femur, right? So uh, all the cross sections area, and it will eventually help me in when I go to the 3D printing, and when I go to the basically .scl generation, or in the meshing also it can help me. And as well as when I go for the implant fitting, and when I see the geometry, it will help me there. And then we have the shortest route, which one is the shortest route available in all of these, so it can directly help me to see that. Moving forward to the surface tools only. So with the help of the center lines, I can directly work on this sweep center lines. So basically it will help in the meshing. So it will generate a tube structure out of all the center lines. So tube type is solid type, and when I click on apply, so as you can see, it has generated some tube structure around the specific center lines. So I can directly work on the radius, modify the radius to increase and decrease its radius size. Moving forward to the design link. So what is design link? So when we are working on any CAD, as we have opened the surface tools. So when we are working on any CAD .stl, or any surface structure, so we can directly import and export it into like SolidWorks. So it has import and export capabilities directly linked with SolidWorks with the help of the design link. And here we have the sync, and here we have the relink option. So this can help us in integration with the SolidWorks hassle free. And these tools I have used. Then go for this editing tools. So I have to create a surface structure out of it first. In measurements, create center lines. So let's create a mask to surface. Let's see the femur left. So I'll go to the mask to surface option available here and click on this femur left. Yes. So for that, I have to click on this up to date surface, and then I have to generate a surface out of it. And after creating a surface, I can work on various things. Like currently, we can see it is the automated segmented surface, or automated segmentation we have done in this data set. So we can use this feature edge editor when we have done any manual segmentation, and we can see uh, any edges or any unwanted structure or edges available in our data set. So we can directly go for the edge editor and directly help it out in that option. Then we have this surface deviation option available. So when we have basically uh, so when we import two different surfaces, so for example I have only uh, imported one surface, or if we are working on the surface, for example if you are working on this data set, so we can create mask to surface out of it also. So it will directly help in to the deviation in that case. So from here we can see the reference surface and the test surface. So we can directly see the deviation in the form of color formats. Then we have the internal structure wizards. So basically internal structure wizards helps us in uh, so when we have acetabular couple, so let me import the acetabular cup again. input and 0 position. So with the help of this internal structure wizard, I can run directly on it. And as well as I have created surface out of it, so I can directly work on this proximal femur left. But for instance, let's work on it now. Let me open software again. Pelvis icon. Wait. Entire screen. And as we have opened this, we'll go for automate segmentation, and then since we have created center lines also and two surfaces also, so it kind of crashed it out. After that, we'll see the measurement options available, and we have other options available in the 3D preview and 3D printing option. So let's wait for the summary. Okay. And then let's click on the generate fast preview. I'll isolate this one, go for the surface tools, and let's first let's create surface out of it. On the mask to surface, proximal femur right, hide input mask. Let's not hide input mask. So let let's go into internal structure wizard. So it has created, it has selected the femur, the surface that we have. So you can directly go in this view section, enable it, and directly see the internal structure wizard that it has created out of it. So basically, it helps us in the when we work on the surface and when we work on the geometries. So it helps us in creating internal structure wizard out of it. So we can directly see in the wireframes as well as edges as well as in the solid. Uh, let's disable it. So we have covered the surface tools option available here. Then we have this volume mesh tool. We'll see after the volume meshing that we have this measurement options available here. So we have first we have this histogram option available here. So we can directly modify the grayscale values in the like in the format of pixels. Then we have this profile line option available. So when we have to work on the histogram, so it will generate a profile line on the histogram. So we can work on that also. Then we have the measurement tools. So as I've told you, it has created the landmarks. So we can generate our own points. We can generate our own line of distance. We can click on this new point, so it will measure the geometry around it. So currently we have this measurements available in the form of landmarks. So it has landmarks available in the anterior superior iliac spine and coccyx femur head, and the number of landmarks you can see here. So these are the landmarks it has generated. So I can directly view its measurements, grayscale values, and I can directly export it according to my need. Next, we have the basically the wall thickness option. So basically, when we are working on any specific data sets, so it with the help of the triangulations, so it generates the wall thickness. Uh, Basically, it sees the volume. As I've worked on the center lines, it sees the volume and it basically check the thickness of the wall inside it, and it can be work as the outwards also and as well as the inwards also. Then we have the 2D contours. So for example, if I want to work on the 2D set, so here I want to see the distance between these and this, so I can directly create the contours out of it, and I can see variety of measurements from here. So for creating the contours, you can use any contours available and directly work like this. Moving forward to the quick statistic analysis, let's open it. Quick statistic analysis, for example, if I want to see the volume, so it has written me the volume fraction, surface area, grayscales. So basically helps us in generating this some quick statistics. Then we have the mass similarity calculator, as I've told you. So if I want to differentiate between, for example, femur right and femur left, so dice score will see currently it is 0. So basically, uh, it will help me to uh, generate the mass similarity in the basis of the dice score. So when we say it's 0, so it's 100% of its efficient quality. We can use the design nick option available here also to export it. Center lines we have seen. In the mass label editor, when we have work on multi-level segmentation, so we can directly characterize it on the basis of that, and we can see the statistics. We can directly generate this specific kind of structures, polygons. So for example, let's work on this. Create. So that is how we can create the 3D structures here, and then we can go for shape fitting. It helps us in the implant only. Shape to shape measurements, we can see shape fitting. We can directly export the reports from here, and we can import X-ray images from here also. Moving forward to the 3D preview. For example, if you have created STL structure out of it. So let me work on that. Let's just delete it. Delete it. So for example, I'll go directly into the, this is femur, right? Go into the model. So from here, I can directly work on this surface model. It has other options also. Let's see that later. So first we have this femur. Right. We want to do the 3D printing out of it. So I'll click on the setup model. It has some options available, and it has export type capabilities available in these formats like .anp, .ansys, .stl. So .stl for the surface option that we've selected. surface settings. Since we have done the automated segmentation, so we do not need any of these. We'll click on close. We'll check the mesh quality and segmentation quality. Let's see the segmentation quality. There is no issues found. We can directly go to the full model generation out of it. So it has created me the full model, surface model, and I can directly go for the 3D printing from here. Similarly, let's delete it. Similarly, if you want to go for the FE meshing, so the process is the same. Models, finite element model, and then we have a setup model option available in which we can do various kind of modifications, smart mass smoothing, and volume meshing. We can set the coarse notch values. We can select 30 in the FE free in the FE grid. So FE free is for all the data we work on, and FE grid is for the complex data set that that we want to work on. So it is hexahedra and tetrahedra options available there. We can go for the placeholder homogeneous and grayscale based material properties. So with the help of this histogram, we can directly change its X and as XSS on the basis of grayscales and Poisson's ratio, Young's modulus, mass density, grayscale frequency, and we can directly update it with the help of the values. We can directly work on the Young's modulus. Moving forward, these are some more modifications options available. We can work on that also. And then we can go for first segmentation quality we have checked. Let's go for the model preview. And now we can directly go for the full model generation. So that is how we can create our FE mesh. So this is the volume mesh. And if we see any structure is unavailable at this, so we can directly work on the primitives available here, the setup model. So we have the mesh refinement option available. So we can directly work on that. And as well as we have this in the help in the surface tools, we have this feature as editor option available. As since after the FE meshing, if we see any dissimilarity here, and after that we can go for the analysis. So for that, let's do the analysis of for example, pore analysis. We can directly go for run analysis from here. So that is all from this session. Also, we have seen full workflow, and we have seen the implant fitting option. We have seen the optimization and performance, and we have seen a lot of measurement options, operations available here to optimize the implant fitting as per our need. We can see the geometries options also available here. So analysis is completed. We can directly see the plots from here. So that is all from this session. So if you have any doubts here, you can directly ask to me, and let me share my screen for the contact details. So that is all from my side. Thank you so much for joining. Uh,